Good morning to all of you. Last class, we will go for summarize the last class topics. We discussed about liquid level. We discussed about that fluid flow and fluid pressure, both. In the last class, we discussed two topics: fluid flow and fluid pressure. In fluid flow, we discussed about orifice plate. So the pressure difference on both sides, which in turn gives the measurement of flow, that is discharge. And another one, turbine meter. Here the rotor rotates. The flow is flowing in a pipeline. We have to bring nearer a turbine meter. That is nothing but a magnetic pickup coil. Then automatically this rotor rotates. Thereby the magnetic pulses obtained. These pulses are counted by a counter. Thereby we can get the measurement of flow. And fluid pressure, or liquid pressure. We discussed in that diaphragm gauge. So here on the diaphragm gauge we have to place a strain gauge. So when the pressure is applied, thereby automatically the diaphragm will undergo a small deflection. That means it undergone strain. So that strain we have to, that is nothing but that is observed by a strain gauge. That strain gauge is connected to the one of the resistor of the Wheatstone bridge. Thereby there will be a change in the resistance. So we can get the output voltage. It is nothing but the pressure, calibrated the pressure. And then next we discussed about um, uh, capsule, 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 and also bellows gauge. Capsule is nothing but it is the combination of two corrugated diaphragms. There is a bellows gauge that is already we explained in one example. It is connected with the core in LVDT, linear variable displacement transducer. By applying the pressure, the core is moving from bottom to top. Similarly from top to bottom. And then next we discussed about the board-on tube pressure gauge. The pressure sense automatically the board-on tube expand. The pressure is less, automatically the board-on tube contracts. Thereby with some arrangement, rack and pinion arrangement, the needle or a pointer moves on the scale which represents pressure. So these are the topics we discussed in the last class. Now today's topic is liquid level and temperature sensor. We discussed now we are going to discussing about liquid level sensors and temperature sensors. Liquid level sensors. In the liquid level sensor, that means it measures the level in a tank. See here it is a float or a bob. Float or a bob. This is a float or a bob. You have to place on the surface of the liquid in a tank. So here when the liquid level rises, the bob is also rises. The bob or float rises. Here this bob is connected with a slider or a wiper. It is a wiper or slider. Wiper or slider. This slider, some arrangement is there. The slider is moving on the, what is this? Anybody? What is this? Anybody? Can you tell what is this? Anybody? Already we discussed it in the previous class. That is nothing but a potentiometer. Here the slider, when the here the bob is floating on the surface of the liquid. Thereby here it is connected with the slider. This is a pivot. This is a pivot here. Here when the float rises, automatically this slider will move on the resistance element. Here the slider, who discussed about the potentiometer, right? We know very well, we know potentiometer. The slider moves on the resistance element. Thereby what happens here, the output voltage also changes. So here, uh, when the liquid level rises, the bob is also rises. Thereby the slider will slides on the potentiometer, it's a resistance element. So thereby the output voltage changes. This output voltage in turns gives the level of the liquid in a tank. Level of the liquid in a tank. This level of the liquid in a tank. This use the level of the liquid in a tank. So here, this is one of the example. Bubbler pulse also is also one of the measurement level. That means here some same tank here one here like this, and then arrangement, some arrangement, right? And then here we are supplying pressure, air pressure, air supply, air with pressurized supply. Here we are supplying from here air pressure supply. When it the air goes into that tank, automatically here we can get some bubbles, right? The bubbles, small bubbles. When the air supply with high pressure, automatically it opposes the here the back pressure. Back pressure is there. So depending upon the back pressure, we can find the level of the liquid in a tank. That is also one of the example to measure the level of the liquid in a tank. And then next we'll go for the other slide. This is ultrasonic type level indicator. This ultrasonic level is a very good one. Where it is used, it's a very difficult to measure the level of a liquid in a tank at high temperatures and some, for example, in boilers and very hazardous situations. In that situation, so it is very difficult to measure by a human being. In that situation, we can use this ultrasonic type level detector. So in this, here the tank is there, here some liquid is there, and here another, uh, here two components are there. One is a transmitter and another one is a receiver. Transmitter and receiver. So here the power supply is there and the electronic processing circuit, or we can also call it as a electronic control circuit, some processing circuit, electronic processing circuitry. Here when the ultrasonic waves, if you send, that means here the transmitter means it transmits the ultrasonic waves. And then it will touches the surface of the liquid, and then it is reflected and it is received by a receiver. And it is received by a receiver. That means from the transmitter, the ultrasonic waves, the ultrasonic is transmitted, right? And then when it touches on the surface of the liquid, and then these waves are received by a receiver. Correct. Now here, what we have to understand here, one major parameter here is there. The how much time period it received by a receiver. That is the time period. Here the time is the here playing here role here. Due to this time period, within this particular time period, this receiver receives this ultrasonic. Then automatically this time period will calibrate it and in turn will use the level in the indicator. Level in the indicator. That means here, for example, if the level in a tank is up to this mark, see here some dotted lines are there. If you clearly observe, these are the dotted lines. If the level is at here, if the level of the liquid in a tank is up to here, that means the time is uh, increase. The time is increase. Thereby, the level decreases. The time period. That means the ultrasonics so transmitted by a transmitter, and it is received by a receiver. The time period is more to received by a receiver, ultrasonic. And then when the level of the tank is this level up to this level, then the time period the received by a receiver this way ray, this ultrasonic is very less. That means the time period at this point is high. So thereby the level of the tank decreases. The time period is very less, is thereby the time period is very less means then the level of the tank is increases. So according to this, the depending upon the time period, where the level indicates in a indicator, which it is displayed and it can easily monitor. And then here, see here, this is a contactless. That means there is no contact here, no contact. This is a non-contact type of sensor. Measurements at hot, corrosive, and boiling liquids. And this frequency is the range in between 40 to 200 kilohertz. The next we'll go for the next one. Now we'll come to the temperature sensor. See here in this level, in apartments, we can get the level of the tank also. How much level? If the level if it reaches the liquid in a particular level of the tank, automatically the motor will shut off. If the level of the water in a tank decreases to the bottom level, then automatically with particular constraint, that is with particular level of that, automatically uh, the motor will automatically the motor. This one we discussed it. That is automatic. That is automatically the motor will on and off. So here, particular level of water it reaches the high position, automatically the motor cut off. When the level of the water in a tank is reaches to the up to a particular level of water in a bottom, automatically the motor on. Thereby the water falls into the tank. It fills the tank up to certain level. That level we can uh, make it constraint in that filling of water in a tank. There also we can use this level measurement device. And if you go for a temperature sensors, temperature measurements, all of you know that temperature is nothing but it is a measure of a degree of hotness or coldness of a particular body or a substance. So now in this, all of you know that thermometer is a temperature measurement device. So here at the end of the thermometer, sensing bulb is there. So in the sensing bulb, mercury is there. When it touches the heat source, automatically the mercury level rises, and the scale which indicates that mercury level, that is scale. In that scale, we can get the temperature parameter, maybe 80 degrees centigrade or 70 like that. So now I will give the brief history about the temperature measurement. In 1600, the thermometers were there. That is a water expansion. That means liquid expansion thermometers. Water expansion or liquid expansion. Liquid here or the mercury. Liquid expansion thermometers or water expansion. And 1650 temperature scales. That means scales degree centigrade, uh, degree Kelvin, like this invented by Boyle. And 1700 standard temperature scales. So these are did not catch. That means did not match. Of course, this not familiar. I hope so. You don't know about this one, Megalotti and Renaldini Newton. The next in 1708 Fahrenheit scale is obtained, and then Celsius scale in 1742, and in 1848 Kelvin scale. These are all you know very well. These scales: Fahrenheit scale, Celsius scale, Kelvin scale. Next, we will go for bimetallic sensors in temperature. This already you know. Already you studied also in physics, intermediate physics. Bimetallic sensors here in this two metals are there, two metals, metal A and metal B. So these metals having thermal coefficient of expansion. This alpha A, that is alpha here. This is alpha is nothing but thermal expansion coefficient. This metal A and metal B having temperatures at T1 and T2. And if the thermal expansion of metal A is greater than B, then the temperature differs. That means that metal A having one temperature, metal B having one. That means T2 greater than T1. If T2 is greater than T1, this metal will bend. This that is due to the thermal expansion. That means when the temperature varies between the two metal, that is the T1 and the T2, the thermal expansion also maybe the varies. That means alpha, that means thermal expansion of metal A is greater than metal B. So here, if you see clearly, it undergone some bending. That is when it is T2 greater than T1. If, for example, T1 is greater than T2, then it comes like this. So here, this is in this the temperature ranges is from minus 75 to 550 degrees centigrade. The accuracy is 0.5% to 1%. And this is one of the cantilever type bimetal. Bimetal means two metals, and then when it is exposed to some temperature source, then automatically it bends. Here, this is bent. Here at the end, it is bending. And same similarly, this is also one of the cantilever, and it is also bent when it is exposed to the heat source or the temperature, then it bends. And if you see in the spiral type of bimetal, when it is exposed to some heat source or temperature, then automatically expansion will take place. So up to this point, up to this point. So here, where this all are used means these are with this. If you the temperature, if it is high, automatically there is an expansion. The temperature decreases automatically. Again, it comes to the original position. Again, all of you when when it is exposed to the temperature or some heat source, it undergoes expansion. Okay, right? Are you understand? When the temperature decreases automatically, again it comes to the uh, initial position. Initial position like this. And then where this is used means in this type of bimetallic sensor is used in cutoff and on devices. For example, take the iron boxes. When you set a particular temperature, for example, you are doing some iron on for example, a shirt, cotton shirt. You have to fix for a cotton shirt or some cotton bed sheet with some particular temperature. See here, you are fixing. That means you are giving the desired output temperature. You are setting in the iron box, and then with that particular temperature, if it reaches automatically, with the help of this bimetallic sensor, it cuts off when the temperature reaches. Remember this point. When the temperature reaches to that, for example, 60 degrees centigrade, you set it in the iron box. So inside bimetallic sensor is there. when the temperature increases, automatically this bimetallic sensor will bend, and then it cut off the current. If cut off the, that means cut off the current means when it reaches to that particular temperature, then only it cut offs. That means here these are used in that applications in a spiral type bimetals. Here, when it is at this position, that means the temperature is normal. When it is exposed to temperature or heat source, then automatically see here there is some expansion movement is there. Here, the expansion movement. So due to this expansion, wherever we can go for apply, then we can apply it, and then mainly we can use these are on off, and also on off means when it reaches to that particular temperature, right? Any examples? Anybody? Any examples? This temperature control. Take heaters. Heaters. We have to set the, for example, if it is in winter conditions, heater is there means, for example, in Ooty or some other places where the weather condition are completely different. It's very cool. Then almost all in houses heaters are there. So they will set the temperature. They will set the temperature with the help of this. When due to the electric source, what happens? The heater will get hot condition, red hot condition. Thereby the temperature increases, right? Uh, that means it reaches to particular temperature, automatically it is an off condition. Anybody, any questions? Next, we'll go for next slide. Pressure thermometer. Pressure thermometer, already we discussed this board-on tube. Already we discussed this is a board-on tube. Board-on tube. This is a board-on tube. Then here the bulb containing, this is a bulb containing gas or a liquid, we have to, whose temperature has to be measured. And then this gas having certain pressure means it is having certain temperature, and then it passes through the capillary tube. So due to the pressure in the gas, automatically the board-on tube, this board-on tube expands. Once it is expands means it is connected with some arrangement. The pointer is connected with some arrangement, and then the pointer will move on the scale, maybe in clockwise or anti-clockwise. This indicates the temperature of the gas in the bulb. That means in the previous we measured about the pressure, right? So that means we can measure, can go for a calibration, right? Maybe here in this particular in this apparatus, we are measuring temperature. In that board-on tube pressure gauge, we are measuring the pressure. Here also, here the bulb containing gas means it is the gas having some pressure. So due to that pressure only, this board-on tube maybe expands or contracts. With the expansion of the contraction, that means we, at the end of the board-on tube, we are arranging some arrangements. This it leads to, in turn, there will be a movement in the pointer. This movement in this direction. The pointer will move in this direction and in this direction. So this scale indicates the temperature of the gas in the bulb. Temperature of the gas in the bulb. Okay, right? Are you understand? Next we'll go for another one. Anybody? Any questions? Any questions? Okay, right. Now we'll go for the next one. Thermocouple. These all of you know thermocouple. thermocouple is nothing but it is two dissimilar materials are joined together, and the junctions are maintained at two different temperatures. That is, one is a cold junction, another one is a hot junction. Thereby, the EMF is produced. That is called this EMF is nothing but electromotive force voltage. This voltage is nothing but temperature in turn calibration. So now that means here thermocouple, it is the measurement of temperature. This whatever I said, this principle, working principle, that is nothing but the Seebeck effect. That means Seebeck effect is nothing but two dissimilar metals or two different metals, A and B, two different metals. That is A. This is A and B. These the two junctions are maintained at two different temperatures, right? Two different temperatures, and that means one is cold junction, another one is a hot junction, and here EMF is produced. That means electromotive force is produced. That effect is called Seebeck effect. Effect is called Seebeck. That means Seebeck. All of you know that Seebeck effect. This is a thermocouple gauge. These are the thermocouple gauge, and or probe. We can also call as probe. Also, we can call as probe. And this is the thermocouple sensor. Inside, it is like this. That means two materials, and this can be measured up to high temperature range and inexpensive. That means, of course, less cost. Uh, some of the members, you better off the video. Manikanta, lateral entry. Manikanta, what are you doing? Manikanta, number lateral entry 13. Lateral entry. Lateral entry of the video. Lateral entry Manikanta. If you want to listen, means you have to stay at one place and then you can listen. Don't wander in outside. Correct? So 313 lateral entry. So 313 lateral entry, I'm unmuting you. Better talk. 313 lateral entry. 313 lateral entry. Lateral entry 13. You are not, I told you that you have to off the video. Correct. Now who will go for, now who will discuss? All of you see here. This is a measurement for high temperature rain. That means it is inexpensive. Inexpensive means the cost is very less. And it is a stand and tough environment. Can use a stand and tough environment, and then it is made of platinum or rhodium, platinum or rhodium, and fast response. It was a very fast response. Output signal is usually small. Already in the instrumentation and control system, uh, you measured with the help of the thermocouple sensor. Thermocouple sensor. Already you measured the temperature. So in a small vessel, you are filling with water, and heater is there, and then the temperature of the water increases. We are placing a thermocouple, or we are inserting in the water whose temperature has to be measured, and then automatically we can get the temperature which is displayed in the monitor, right? The next we'll go for next one. Any questions up to this? Thermocouple. Thermocouple is one of the device which is used to measure the temperature. The next, if you go for thermistor, right? Thermistor. This is very small sensitive element. This is very small sensitive element. So here, thermistor means here thermal, right? And ISTOR is nothing but a resistor. It's nothing but thermal resistor. Thermal resistor. This thermistor, it works like a resistor. When this resistor is exposed to a heat source or temperature, automatically this resistor, there will be a change in the resistance. It's a element is this resistor element is a very sensitive element, inexpensive. Of course, inexpensive means the cost is less. Reasonably we can get accurate, but here in this typically it is a negative temperature coefficient, negative temperature coefficient, and also sometimes positive temperature coefficient also. And here glass bead disc or a chip thermistors, these are see here in this it is made up of manganese, nickel or cobalt oxides, which are milled and mixed in equal proportions with binders, and it is pressed into desired shape. These are the desired shapes. See here. Uh, these are the desired the shapes. See here. These are the leads. These are the leads, right? These are the two leads, and this is the thermistor. And so here pressed into desired shape and then sintered to form these thermistors in the form of beads, rods, or discs. So this is very, see here, a small element. This is very small element. It is made up of manganese, nickel, or cobalt oxides. See here, it is exposed to where the temperature of a substance we have to measure, or how to place it. So what happens? I told you that thermistor means it is nothing but a thermal plus a resistor. When it is exposed to heat source, automatically there will be change in this resistor. If there is a change in the resistor means explain the fundamental. And here, see here, it is connected to the thermistor. This is the thermistor RX, R1, R2, R3, R4. This RX is connected to the one of the resistor of the Wheatstone bridge. Thereby, the resistance changes. When resistance changes, when this thermistor is exposed to the heat source, whose temperature has to be measured. So then automatically there will be change in the resistance in the thermistor, and we can get the voltage. This voltage in turns gives the temperature. So, Mr. Manikanta, okay, right, no problem. I observed that his phone is hanged, right? Now you are in the class, number 13, lateral entry. 13, lateral entry. Now you are in the class, right? Just I placed you in waiting room. Now you are there, right? Right. Okay. Here, when you enter into the class, we have to maintain discipline, right? Number lateral entry 13. Hmm. Okay, I hope so. I understand. In your area, the network is not available. I hope so. That's why you are wandering on the road. Huh? Where your house is? In village? Mr. Lateral entry 13. Lateral entry 13, Manikanta. Okay, right. Which village? Manikanta. Name of the village. Okay, right. Okay, right. I understand your problem. But anyway, you have to once if you switch off your video, then you can get a network, and then whatever I delivered, it is audible to you. Correct. Better. That means when you on the video, what happens? The net consumption increases. So better you can switch off the video. When I ask you any question, means then you can switch on the video, and then you can answer to my question. Okay, right, Manikanta? And this Dharmishter, right? Okay, any questions, Dharmishter? Okay, next we will go for another one. RTD, resistance temperature detector. This is also, you see here in the word itself only it is there, right? Uh, resistance, it is a resistance temperature detector. See here, this is a resistance temperature detector. These are the, right, small, these are the leads, these are the two leads, and it is a very accurate and stable, reasonably wide temperature range. It's more expensive. That means cost is high. RTD is cost is high compared to the thermistors as well as the thermocouples, and it gives only the positive temperatures. Whereas thermocouple we can also measure the negative temperatures, but this RTD we can measure only the positive temperature constant, and rather positive temperature constant requires current excitation, small resistance range. This is also same similar resistance temperature detector. Here there will be change. It is also made up of platinum. Uh, this exposed, or we have to place where the temperature of a liquid or the temperature of a gas has to be measured. Then automatically there will be change in the resistance on this element, and which is connected to the Wheatstone bridge, one of the resistor. Then automatically the voltage, you can get the voltage. This in turn leads to you can get the temperature parameter, right? So now any questions? Any questions? Any questions? Uh, for today's topic, any questions? Anybody? You can ask the questions. Questions? Any questions? So today we discussed about liquid level and temperature sensors. Liquid level we discussed about float or bob, which is placed on the surface of the liquid, whose level of a liquid in a tank has to be measured. Then automatically the bob rises or decreases. Then automatically, which is connected to the pointer. This pointer slides on the resistance element, which is called a potentiometer. So thereby, there will be change in the resistance. This change in the resistance will in turn give the voltage. This voltage gives the which on calibration the voltage gives the level of liquid in a tank. And then next we discussed about the level, liquid level. Another one, ultrasonic type. This is this especially this used in where temperature has to be measured at high ranges, very difficulty. Maybe the temperatures around 1000 degrees centigrade or 1500 degrees centigrade. At that places we can use this ultrasonic type level detector. It's very where the human beings can work very difficulty in that situations. So with the help of this ultrasonic type level detector, we can find the level by sending the ultrasonic rays, and then it will touch us on the surface of the level, and then it reflects and then received by a receiver. And then here the mainly depends upon the time, how much time taken by a receiver to receive, depending upon the time. If the time is very less, then automatically the level of the liquid in a tank is high. If the time is very high, the time period, then automatically the level in a tank it is a very low level. And then temperature sensor, we discussed about bimetallic sensors, right? Pressure thermometer and thermocouple and thermistors, resistance to temperature detector, RTD. So, okay, right now, any questions there or not? Or you understand? All of you understand? All of you understand? Number 304. Okay, 338. Raviteja. Okay. Yes. Now I will take the time means you have to respond one by one. But just you have to post a message in the chat box. 301, 301, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right, 26, okay, 27, 27, 28, okay, right, 29, 29, 30, 31, 32, 33, 35, 36, 37, 38, 39, 40, 40, 40, 41, 41, 42, 43, 44, 45, 46, 48, 48, 49, 50, 52, 54, 55, 56, right, 60, right, 61, 61, 63, 64, 65, 66, 67, 68, okay, right, 69, 60, 68 present, okay, right, 69, 70, okay, present, 73, 74, 75, 76, 77, 77, right, 78 present, 79, 80 present, 81, 83, 84, 85 present, okay, 88, 89, 90, 91, 91, 92, 93, lateral entry 1, 2, 2, 3, 4, 5 present, 6, 4 present, okay, 7, 8, 9, 10, 11, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, right, 21, 22, 23, right, present, 23 present, 24, 25, 25, 26, 27, 28, 29, 29, 29 option, 30, 30, right, 31 present, 32, 33, 34, 35, 36, 37, 37, 38, 38, 39 present, 40, 40, 41, 43, okay. Here the absent is just I am reading. All of you check it. 5, 7, 9, 10, 15, 17, 18, 19, 24, 27, 29, 30, 39, 42, 48, 50, 55, 61, 65, 67, 69, 74, 76, 77, 78, 89, 91, lateral entry 2, 3, 11, 16, 17, 25, 29, 30, 17 present lateral entry 30, 32, 38, 40, 41. 305%. Okay, right. You are given present. And then next, the quiz is appearing from 11 onwards to up to 6 p.m. in the evening. You have to write the quiz exam, right? So now, okay, right. Thank you, all of you.